is lesson 1.6. Lesson 1.6 is talking all about angles. We're going to be describing pairs of angles. Okay, let's jump right into our first exploration. What do you notice about the following angle pairs, x and y? Let's start with x and y. Let's just look at those two angles right there. Okay. And I want you to, as we go through this, or through these, I want you to think, if you can come up with an answer, think of an answer in your head and see if you're right. So what do we notice about those two angles? Well, the first thing that jumps to mind is maybe that y, angle y, is a bit bigger than angle x. Right? It kind of looks like angle y is an obtuse angle. We know what obtuse means. It looks like angle x, is acute. And another thing I might notice is that it's on, both angles are on that line, this blue line. Okay? This line equals 180 degrees, right? You'd agree with that. We've learned that in the past, that lines are 180 degrees. A flat line is 180 degrees. Well, if that whole line is 180 degrees, then x and y have angle measures that add up to 180 degrees. Okay. Let's move on to our next angle pair, y and z. Well, won't you agree that if x and y are on that other line, won't y and z be on this line right here? I know my line's a little off. Right, and the line equals 180 degrees. Therefore, y and z, won't they add up to 180 degrees? And lastly, x and z. Let's look at these measures. We have x and we have z. Just come up with something in your head. Those two angles, what do they look like to you? X and z appear to be equal. Maybe. Okay, it's just something we notice. All right. And we'll get into this in a little bit here. Let's move on to the second part. Find the values of the indicated variables. Do not use a protractor to measure the angles. Okay, do not use a protractor. We just have to find it based on our information. Well, angle x. Angle x, how would we find that? First thing I look for is a number, because we know numbers. We can work with numbers, especially if we want to find the variable, or if we want to find the value of the variable. We have to somehow find a number. And x and 108 degrees. Those two numbers next to each other. Those two angles next to each other. They're both on that line. Right? Again, this line equals 180 degrees. Well, if x and 108 both add up to 180 degrees, we know that x equals, well, x plus 108 is equal to 180 degrees. Right? 108 degrees. Or, yeah, x and 108 equals 180. If we take x, right, and measure x, and the angle of 108, that whole measure, x and 108 equals 180. That's why I set up this equation. If I subtract 108 from both sides, I come up with x is equal to 72 degrees. Okay, that's good to know. Next one, y. What does y equal? Well, a couple ways to find this. We can say x and y are both on this line, right? And again, this line equals 180 degrees. Well, if x is 72, then 72 plus y, 72 plus y is equal to 180 degrees. If I subtract 72, I get y is equal to 110 degrees. Oh, sorry, not 110. Whoa, bad math. 108 degrees. Okay. If y is 108, I want to see if you notice this. If y is 108 degrees, what do you notice about these two angles? They're equal to each other, right? Angles that are across from each other, in terms of across an x, right? If I have down here, I'm going to draw an angle or a line here and a line here. Okay, imagine these are lines intersecting. They make 4 angles. Well, this angle here, colored in blue, is equal to this angle here. And colored in green, this angle here is equal to this angle here. Those are called vertical, where am I? Right here. Vertical angles. Angles that are across the x from each other are vertical angles. Knowing that information, we can find z. We can find z, because if x is 72, then z is 72. Z is equal to 72 degrees. The measure of w, okay, this one's a little trickier to find. This one is a tad trickier to find. Looking at this, if this is a perfect star, let's erase this. Let's look more closely at our variable. W. Okay, well, we know z is 72 degrees, right? This is 72. This is 72 degrees. How would they expect us to find that? Sorry, I'm just looking at the book quick. I don't want to jump into information we haven't learned yet. So I'm just looking. Okay. So it jumps from here. The 5-pointed star has a regular pentagon in the middle, right? Which means that each of its angles are 108 degrees. This is a little deeper thinking, right? Those are all 108 degrees. Now W would equal, they're on this line. W equals 180, or W plus 108 equals 180 degrees. We subtract 108, W is equal to 72 degrees. Okay, and then V, well, if Z is 72 and W is 72, we know that the measure of a triangle, so I'm going to write this here, a triangle is equal to 180 degrees. Okay, we know that the area, or the interior angles of a triangle add up to 180 degrees. So V plus 72 plus 72 is equal to 180. If we add 72 plus 72, we get 144 is equal to 180. Subtract 144, we get V is equal to 36. And that's how you find W and V. Moving on. What do you notice about the following pairs? Okay, again, what do you notice? A and B. A and B. That looks to be a right angle. So appears to equal 90 degrees, right? A and B. 90 degrees combined, I'll say. C and D. C and D. They're on that straight line, right? So add to 180 degrees. And then lastly, what's this last one? Is it C and E? C and E? Well, we talked about that, right? They are, C and E are equal. And both are 90 degrees. Part B, we're finding the values. Yeah, all right, so we're finding the values. Let's find the value of C. Well, again, we have to find the value. We know that this right angle thing here, that's 90 degrees. Right, that little square there makes it 90 degrees. Well, if that's 90 degrees, and C in that 90 degree on the straight line, we know that C plus 90 is equal to 180. If we subtract 90 from 180, we know that C is equal to 90 degrees. Measure of angle D. Well, we could either say 90 degrees plus D is equal to 180, or we can just look at the vertical angle, D and this 90 degree. We know that D is equal to 90 degrees. And the measure of angle E, well, we know that's 90 degrees. All three of those angles in the middle are 90 degrees. How can you describe the angle pair relationships and use the descriptions to find angle measures? Well, we know that when two lines intersect, four angles appear. Okay? The angles next to each other add to 180 degrees, and the angles across, oh, I can't spell, across from each other are equal. Okay? Moving on. Number 4, what do you notice about the angle measures of complementary angles, supplementaries, and vertical angles? We don't know those definitions yet. We're going to get into that right now. Complementary angles. Complementary angles are angles that add to 90 degrees. This is a very important definition. Make sure you get these definitions down. Add to 90 degrees. Supplementary angles add to 180 degrees. Okay, these two definitions, very important. We will be using these in the future. Adjacent angles are angles that are right next to each other. A linear pair. A linear pair. Here, I'm going to erase these so we get a little cleaner. A linear pair. What's in the word linear? The word line. Okay, so a linear pair. Let's start with this line, and let's say an angle or another ray is drawn off that line. That forms a linear pair. We have this angle here, and this angle here. A linear pair add up to 180 degrees, or are supplementary. Okay. Vertical angles, I talked about that earlier. Vertical angles, if we had a line and another line. Okay, vertical angles are across from each other. Okay, vertical angles are across from each other. They are equal. Okay. Moving on. Here's some definitions. Talk about all the definitions we kind of just went through. Okay, this extra practice. Name a pair of adjacent complementary angles. I'm going to pause the video. I'll be back in a minute. Okay, doing these practice problems. We have to name the pairs of adjacent complementary angles. So first thing, adjacent. Remember, adjacent means next to. Okay? Complementary means equals 90 degrees, or adds up. Adds to 90 degrees. Okay? So we need a pair of angles that are next to each other and add up to 90 degrees. Well, we can start with these two. We can start with KJL and LJM. But do those add up to 90 degrees? The answer is no. LJM is bigger than 90 degrees. So it's something over in this group of angles. Okay? Which of these angles add up to 90 degrees? Well, there's STP, right? Or SOT and POT. So that is our answer. Angle SOT and angle POT. Next, we have the name of the pairs of non-adjacent. Non-adjacent. Okay, if adjacent means next to, what does non-adjacent mean? That means not next to. Okay, and then supplementary. Supplementary means add to 180 degrees. So, we need something that's not next to each other and adds to 180 degrees. For example, well, adjacent supplementary angles would be something like 75 and 105, right? They're next to each other, they add to 180 degrees. We want something that's not, or not next to each other. Okay, I'll just give you a quick example. We have LJM at 105, so LJM. We also have, that's 105. We need a 75 degree angle. So there's ROQ and angle ROQ. There is another one. And I'm gonna let you try to find the other non-adjacent supplementary angle. Okay. Next down here, we have 3 and 4. Angle A is a complement of angle B. Complement. Complement, what does complement mean? That means 90 degrees. So if they add up to 90 degrees, and angle A is 36, we know that 36 plus angle B is equal to 90 degrees. Subtract 36. We get angle B is equal to 54 degrees. I'm going to let you guys work on number 4. A supplement means 180. 180. Okay, and I'll let you guys work on that. Next, number 5. Find the measure of each angle. Okay, so we'll have to use some manipulating here. Notice, BAD is a 90 degree angle. So this angle plus this angle add up to 90 degrees. They're complementary angles. So we have to add them together. 10x plus 22 plus 7x plus 34 equals 90 degrees. From here, combine like terms, we get 17x plus 56 is equal to 90. 17x is equal to 34. Okay, divide by 17, we get x is equal to 2. Go back, read the question. What did it ask? It said find the measure of each angle. We have not found the measure of each angle. And we have to take what we have here, and we have to plug it in. Okay, so 10 times 2 plus 22, that is 20 plus 22, we get 42. 42 degrees, right? And we have to plug it in here. We have 7 times 2 plus 34. We have 14 plus 34. We end up with 48 degrees. Okay, so multi-step problem. You guys, I'll get you started on number 6, but I want you to work on it. This angle is equal to 180 degrees, right? It's a straight line. So we know that 6x minus 5 plus 12x plus 5 equals 180 degrees. And I'll let you guys work on that. 7, 8, 9. Identify linear pairs that include angle 1. Okay, linear pairs, line. The word line is in linear pair. Right? It's an angle with one that creates a line. Well, we have this line right here, right? That includes angle 1, so we have angle 1 and angle 2. We also have this line, which is angle 1 and angle 4. Good. Identify the vertical angles. Okay? Vertical angles. We have 1 and 3. We have 2 and 4. We have anything down here? Yes, we have 7 and 10. We have 5 and 8. And we have 6 and 9. So multiple vertical angles there. Okay, I'm not going to write or list all of them. I kind of just did the polka dots. You guys can list all of those. And then it asks, number 9 asks, are 6 and 7 a linear pair? 6 and 7. Well, 6 and 7 are on that line. But the answer is no. Why is that? Because of this angle right here. 7 is this angle. They are not supplementary. So not supplementary. Okay, that is the end of the video for 1.6.